to our third episode of our webinar series on methodologies for greenhouse gas baselines and monitoring in the transport sector. My name is Urda Eichhorst. I work with GIZ and I'll be moderating today's webinar. We have today's webinar is focused on fuel pricing policies, and I'll introduce our colleagues from Interest Institute and Vera, formerly VCS, in a minute. But before I do so, I would like to just give you some technical inputs for those who are not familiar yet with the GoToMeeting software. The most important actually for you is the questions pane that you find towards the end of the control panel. And this can be used to pose questions to the speakers. And we would like to collect the questions throughout the presentations, but we'll first go through the presentations and then have a Q&A session in the end where we'll collectively respond to all the questions. Everybody is automatically muted, so the only way for you to, unfortunately, to interact is through the questions pane. And some other, if you need to change the language, you can also find it in the control panel. We have about 90 minutes ahead of us. I'd first like to give a little bit of background on the passenger and freight transport volume. And then Sinclair Vincent from Vera, which was formerly VCS, and I think she'll explain a little more about it, will give us the background on the transport pricing guidance that was actually developed under the Initiative for Climate Action Transparency. And then Felix Weber from Infras will lead us through the emission quantification methodology for fuel pricing policies. So our speakers today, as I mentioned, Sinclair works for Vera, and also as part of that for the Initiative for Climate Action Transparency, and was part of the guidance development team. Felix works at Infras on a broad range of issues on environment, climate, and energy, but he was also part of the team and also one of the lead authors of the transport pricing guidance. And therefore he will also present them to us in more detail. I'm your moderator. I work with GIZ as an advisor on transport and climate change, and have also managed the transport volume on behalf of GIZ, which we developed together with the UNFCCC Secretariat. So a little bit of background on the passenger and freight transport volume. And by the way, I've uploaded the volume into the handout section in the control panel. So from there, you can download the volume directly. And also in the handout section, you find the PowerPoint slides of today's presentation as well. So the passenger and freight transport volume of the Compendium on Greenhouse Gas Baselines and Monitoring, as you can see, was developed as a joint effort by a range of institutions as a multi-stakeholder effort coordinated by the UNFCCC Secretariat. And it's one of several volumes. Other volumes are coming along and will also be published later throughout the year on other sectors like industry and agriculture and land use and so on. So in our volume on transport, we have 8 chapters on the different types of mitigation actions. And for each of these 8 chapters, we are now organizing one webinar to introduce the respective approach to setting greenhouse gas baselines and monitoring. And today we're talking about fuel pricing policies. So what can you expect from the volume? First of all, each chapter on each of the mitigation action types starts with outlining the impact chain. And this is an approach that was actually developed also as part of the greenhouse gas protocol to identify the main impacts of a particular intervention. And this should just give you an easy overview on the main indicators that you need to look into for a particular mitigation action type. So it shows the different variables that are targeted by the mitigation action and how you would expect them to be affected by that particular intervention. And what you can see here is the example from the fuel pricing policy that is now in Chapter 8. And in fact, this is the second revised edition of the volume, because since Chapter 8 also came out of this ICAT process, it was developed only more recently than the rest of the volume, which was already published last year. Then what you find in addition to that is a guide to the different tools that have been developed for that particular mitigation action type. Now, this is an example from comprehensive urban transport programs and plans for which more tools already exist than is the case for the pricing. So you find this navigator that allows you as a first glance to look at what tools might fit the purpose of your analysis best in terms of level of accuracy and the objective of your analysis. Is it an ex-ante assessment or ex-post? So we try to map those in a very simplified way, of course, as a first access to the different methodologies that exist. But then you get more detailed information on each of these methodologies in each of the chapters that allow you a little bit better assessment of what particular methodology might be most useful for your particular case. So overall, the transport volume and the compendium is really like a navigator through the landscape of existing methodologies for monitoring and reporting. And this is also the purpose and the background of the volume or of the compendium. That is, that the idea was that there's now an increased demand for quantifying emissions in the different sectors, and for many of our partners and in developing countries, this is like an issue that does not seem a little bit worrisome in the beginning. And so the idea was to say, okay, we don't have to start from scratch everywhere. There actually are there's a wealth of methodologies out there that can be used and applied. We don't have to develop everything from the start again. So this is really a navigator through the existing methodologies that exists. And it's now available with its update. And of course, you can also just download it from the handout section. And with that, I would like to leave it and hand over to Sinclair.
Thank you, and thank you everyone for joining today. So I'm just going to give a brief introduction to the Initiative for Climate Action Transparency, or ICAT as we call it, before we jump into the method. So let me just make sure my mouse is working here. Just a moment. There we go. So the objective of ICAT is to provide policymakers with tools and support to measure and assess the effectiveness of their country's climate actions in line with the Paris Agreement. So the two main outputs that you see here are designed to help countries monitor, report, and verify progress on their climate commitments. The first being the ICAT series of guidance, which is guidance to help countries assess the greenhouse gas sustainable development and transformational change or transformational impacts of policies and actions in an integrated way. And the second output is capacity building, where we are supporting around 20 partner countries towards improving policy design and their impact assessment capacity. Let's see. So it is a multi-stakeholder partnership. ICAT is funded and overseen by the 4 donor organizations that you see at the top of this slide. and involves 3 main implementing partners, including the UNFCCC Partnership, or UDP, Vera, and the World Resources Institute. And a quick note on Vera, as you may have seen in our recent announcement, VCS is now called Vera as of last week. And there's a post on our website if you'd like to know more about that change. The initiative is also supported by a number of other organizations shown here on the screen, including our colleagues from INFRIS that are here with us today. And then we also had 10 different working groups comprised of nearly 160 members that contributed to the development of the guidance. So what does the guidance cover? I'll give just a quick overview of the whole series and show you how the transport guidance fits into that. So ICAT provides a toolbox of guidance for the assessment of greenhouse gas, sustainable development, and transformational impacts of policies and actions. The series of guidance is comprised of a number of different documents, as you can see here. So at the top, you see the introductory guide, which explains how the guidance documents actually relate to each other and can be used together. And then in the light blue section here is the core set of impact assessment documents, which cover several different sectors for greenhouse gas impacts, as well as the sustainable development and transformational change assessment documents. And then these are all supported by further guidance on topics like stakeholder participation, which are shown here in the dark blue section. So you can see that the transport pricing guidance is part of that core set of documents, and that's the method that we'll be presenting today, given that it's also part of the compendium. The guidance was developed to be flexible. Users are recommended to start with this introductory guide and then can move through the guidance or even a single document in any order or combination that meets their needs. So users, who can use this guidance? The guidance was intended for actually a wide range of organizations, institutions, or individuals, including all those that you see on this list, each of which may have their own objectives for assessing impacts. The flexible approach that I mentioned of the guidance allows users to apply the guidance for their various needs. The main audience, though, is governments and the consultants that they work with, who can assess the impacts of policies and actions to inform policy design, monitor progress of implemented policies and actions, or retrospectively evaluate impacts to learn from experience. But a number of others can use the guidance, such as donor agencies and financial institutions who might be looking to assess the various impacts of finance, such as grants or loans that were provided to support policies and actions, including results-based financing. So the goals for using the guidance depend on the user's needs. The documents each provide guidance for ex ante or forward-looking assessments, as well as for ex post or backward-looking assessments. And the focus of ex ante assessment is on sort of deciding, as you can see in this top left circle, so to inform policy design and implementation, or perhaps even to choose between 2 or 3 different policies based on an assessment of the expected impact. Whereas the focus for an ex ante assessment is understanding or evaluating what the actual impacts of a policy have been. And then lastly, for both ex ante and ex post assessment, the guidance can help support reporting, whether it's for domestic or international audiences. So this is sort of how we were and continue to approach the work following these principles in the guidance development. So the first is enabling. We want the guidance to be as user-friendly as possible. It's not a set of rules and requirements. Flexible, as I mentioned, it's non-prescriptive, and the goal is to have it accommodate varying national circumstances. Leveraging, the guidance very much builds upon existing and emerging work. We're not trying to start from scratch and wanted to build upon all the good work that's already taken place in this space. And then finally, participatory. So we've engaged stakeholders broadly throughout the development process. So finally, I wanted to show sort of the full process and our timeline here, and also note just how we have incorporated stakeholders. So stakeholders have been and will continue to be involved at multiple points in the process, including through the technical working groups that I mentioned that helped draft the initial guidance documents. Those first drafts were posted for public consultation back in August of last year. We received general feedback for the whole series of guidance, including some input that documents were quite lengthy. So we're now sort of working on determining how best we can either modularize or just make the documents more approachable and more easily digestible. And then specific to the transport pricing guidance, we received feedback such as needing to provide a little bit more explanation or guidance around helping the user actually select the most appropriate approach for their country circumstance in their assessment. So we're now working on addressing the feedback received, and the second draft for the series of guidance is due to be released a little bit later this spring. Another focus for 2018 for ICAT is piloting the guidance in country, which will give the end users a chance to provide direct feedback to be incorporated in those final drafts. We'll then open the reworked guidance for a final round of public consultation. And again, the goal here is to make sure that throughout the development process, we're tailoring the guidance to meet the needs of its intended users. So if anyone has questions about ICAT more broadly or this process, you can raise those at the end of the presentation. With that, I think I'll hand it over to Felix to get us into the actual methods in the transport guidance.
Thank you, Sinclair. Yes, welcome also from my side to this webinar. I'm very happy to have the opportunity to present to you the methods as we describe them in the transport pricing guidance. Just as a short note in the beginning, the transport volume chapter has about 10 pages about this guidance. And the guidance itself is about 150 pages. So that's a very condensed version of the real methodology we describe in the transport pricing guidance. And I will be able to go a little deeper in this webinar, but obviously I can also only give you an overview over this transport pricing guidance. So there we go to the next slide. Perfect. The purpose of the guidance is to provide guidance for a variety of users to assess the impacts of pricing policies in the transport sector. So it's very important, and I want to emphasize this, that there is simple guidance, straightforward approaches for any sort of policymaker or practitioner. And the idea is that the results of the guidance can be used in the context of NDCs, NAMAs, and so on. So the applicability, because we want to keep it simple, is obviously a little, it's not applicable throughout all of the possible pricing measures you might think of. So the most important two elements we address are fuel subsidy removal and increased fuel tax or levy. What we do not have in the compendium chapter, but what we have in the guidance is some further indications on road pricing and on vehicle purchase incentives for more efficient vehicles. So let's have a little look at the guidance document. It consists of 4 parts. In the first part, is an introduction and an overview over the assessments. And then the second part, that's the real guidance starting. So we show users how to define their specific assessment. And then part 3 is the one I'm going to focus on today, about the impact assessment. And then in the final part, what Sinclair was mentioning before, it's about monitoring and reporting, and maybe also some ex post analysis. So let's move into that part 3, assessing impacts. We defined 4 assessment steps, which I want to present to you shortly. So the first step will be to choose the appropriate approach for the circumstances you are facing. And we have 3 approaches, A, B, and C, which I will talk about in a minute. Then the second step will be to estimate baseline emissions, to have a baseline scenario which you can then compare to the policy scenario, which you will define or estimate in step 3. And the policy scenario depends on demand impacts, specifically on how demand is impacted by higher fuel prices. That can be because of a higher tax or also because the removal of a subsidy. And in that step, we work with price elasticities, which I will also talk about later. And then the last step will be to estimate the greenhouse gas impacts based on step 2 and 3, so based on the baseline scenario and the policy scenario. So let's have a look at those 3 approaches. This table gives you an overview of how the approaches are distinguished and how you may also choose which approach is most suitable for the circumstances users may be facing. Approach A is the most simple approach. I said that before. It's important to have a simple approach that is feasible to apply for anyone, maybe with not so much data availability, maybe also with not so much capacity. So approach A is the real simple approach, where we look at general fuel consumption. It's on the national level, it's only ground transport, and you can also just work with data on a fuel mix, so just knowing how much fuel is used in your country. Approach B is an extended version of approach A. I will not be able to go into that approach B specifically. It is also not described in the Compendium chapter, but there is more information in the transport pricing guidance. And then approach C is the most complex version of assessments. It requires more data, so you can see here that we have a comprehensive bottom-up travel activity data is required. For example, that might be the distance traveled in one transport mode. It is restricted to a regional or urban geographical boundary, and we can only look at passenger transport in an urban context with approach C. But you can obviously combine several assessments for several cities, for example, to have a larger picture in geographical sense. And then you can also distinguish specific fuels, for example, gasoline, diesel, or electricity. So let's now move to approach A. I will give you an introduction with a specific example, and you can always see on the top right corner of the slide, you can see in what step we are currently what step we are currently discussing. So let's assume for approach A we have the following situation. A government plans to implement a national fuel levy, and they don't have a lot of data. They just have a total annual energy use in the transport sector. So in that situation, we will apply the very simple approach A. So let's move to step 2. The next step will be to define the baseline emissions. That's a simple top-down approach. Users will have to compile activity data, which is just fuel used. If possible, users can share the estimate of different fuel types. If that is not possible, or if there is no good guess, you could say it's 50-50, for example, between gasoline and diesel. So just to show you how simple the approach is. And finally, the users will compile emission factors, and there we have an order of preference. So the best situation would be that there are emission factors from a national energy or environmental statistic available. Then the second best option is if there is information provided by national fuel providers. And if that's also not the case, there are default values provided in the transport pricing guidance. So with that data, if you multiply the activity data and the emission factor, you will get your base year emissions. Just to show you an example of how to project these emissions, these base year emissions, to a baseline, there are two options in the guidance. Option one is, again, a very simple method for projecting. So you would have as input data for one specific year, let's say it's 2016, you have the fuel use in the transport sector for the year 2016, and you have the population number for 2016. If you divide that, you will get a fuel use per capita, and the most simple assumption would be that this fuel use per capita is constant over time. And if you have that information and you have a population projection, you can multiply those two things and you will end up with a fuel use projection. That's the very simple approach. And again, the guidance also gives information on more advanced methods that could be comparable growth rates, trend analysis, or modeling. And I will not go into detail here, but just that you see the guidance gives different options to proceed with different complexity levels. So now to show you that in an example, let's say you have a population projection here that starts in year Y, let's say it's 2016, with 50 million, and then population is increasing over time. You can see we have 5 projected years in that case. And then you have from fuel use in that year and from the population, you get a per capita fuel use in 2016, which you keep constant throughout the time series. And coming from there, if you multiply that, you will get your fuel consumption projection. And if you have a emission factor, if possible, a country-specific emission factor, then you can calculate baseline emissions. You can see in that case, gasoline and diesel, it will be the simplest assumption that it's just divided 50-50. So in that case, in 2016, there would have been 56,000 kilotons of CO2, just to keep that number in mind when we go on with the example. So then we can move to step 3, fuel demand impact. As I said before, we are looking at the question how a change in fuel price affects fuel demand. And for that, to answer that question, we use own price elasticities. That means that if the price of the fuel changes by 10%, then demand may change by -5%, demand of that fuel. So the own price elasticity of demand will be the demand change divided by the price change, which will be -0.5. So if you, as you see in that figure down here, if we move the price from P2 to P1, we have an increase in price, we would have a decrease in demand. And that curve here will be the demand curve, or that determines the elasticity. So the assumption with this definition, with this demand impact, will be that by increasing the fuel price, you have reduced vehicle travel, you have an increased switching to more efficient and alternative fuel vehicles, and you have an increased switching to different transport modes. That's very important. This is just the basic assumption that determines that the demand impact will reduce greenhouse gas emissions. So you will now have to choose appropriate own price fuel elasticities to apply the approach. So again, it's recommended to use country-specific price elasticity data. That's usually data from empirical studies. But if that's not available, the guidance provides default own price fuel elasticity values. And those are adapted from a study from Carol Dahl in 2012 she looked at elasticity, empirical elasticity values from different countries, and then built this table, this sort of framework that is applicable to most of the countries worldwide. So to make an example, if our country that wants to apply approach A of the transport pricing guidance has an average income in 2016 of about $13,000 per capita, so it's important that's the average income, then we are in this middle column. And if that country has an average fuel mix price of 40 cents per liter, then we are in the middle row, which then gives us a own price elasticity of demand that equals minus 0.24. So that's how you can determine the default own price elasticity value. Again, to repeat that, it's better, obviously, to use a country-specific price elasticity value. Okay, so when that's done, the next step will be to estimate greenhouse gas impacts. So again, this assumption, the increase of fuel price leads to a decreasing demand of fuel. And then coming from that, we have a reduction in greenhouse gas emissions. So the difference between the greenhouse gas emissions in the policy scenario means with the policy scenario depends on the demand impact. And the difference between that one and the baseline scenario will be the impact of the fuel pricing measure. What we need to calculate, to proceed with step 4 is from these earlier steps 2 and 3, the baseline fuel use and baseline emissions, then the own price elasticity, which we determined before from the default value, and then obviously the relative fuel price increase, which is given by the policy, which you defined in part 2 of the guidance defining the assessment. So to finish the example, again, with those numerical, with those numbers here. So we come from step 2 and 3, where we have the baseline emissions, those 56,000 kilotons. Here it's in tons of CO2, so there are more digits. And we have the fuel demand impact with the own price elasticity, which is minus 0.24. And then we have in row D, the real relative fuel mix price increase, which comes from the policy, how it is defined. And then the coming rows are the calculations. As you can see, maybe you know that system from the IPCC guidelines, the equations in the column data collection calculation, they are based on the row labels. And you can see here, I will not explain the equations in detail. They are not very complex, but as you can see, that would be then an anticipated greenhouse gas impact of minus 600,000 tons of CO2, which equals about a reduction of minus 1.1% in greenhouse gas emissions from the transport sector. So now it's important to have a good interpretation of those results. And the first thing and most important thing I want to mention here is that we are dealing with quite high uncertainties in that very simple approach A. We have uncertainties in the activity data estimation. We have uncertainties with different factors, the emission factors, other conversion factors like net calorific values. We have uncertainties with the projection of our base year emissions. And we also, and that probably is the largest uncertainty, we have uncertainties with the estimation of price elasticities, own price elasticities of the fuel. And that's obviously even more, even higher. Those uncertainties are even higher if you use default values provided in the guidance. So that's why it's very important to first know that there are these uncertainties, that the approach bears these uncertainties, and it's crucial to be transparent about that. And one thing we recommend in the guidance is that you indicate a range of possible greenhouse gas impacts rather than just a single value. So in the example before, we have minus 1.1%, maybe that would be between minus 0.5 and minus 3%. Or there is guidance, I mean, there is some specific description regarding this, but it's important to know that there are high uncertainties with that simple approach. Good, and with that, I would like to move on to approach C, which is the more complex approach. We have a very different situation in that case. So the government maybe also wants to assess the substitution of individual motorized transport by car with public transport. So obviously we aim at much more detailed results, and we also need much more detailed data. The general assessment steps are similar than they are for approach A. So you can again see in the top right corner in what step we are currently moving. So I will, for this approach C, not describe the whole approach. I will just make clear what are the differences between approach A and approach C. So I will not go into detail with numbers. So the first thing we have to know is that with approach C, we have different system boundaries. I already mentioned that in the beginning. So we focus on passenger transport. The guidance does not specifically give guidance on freight transport for approach C. And we focus on urban public transport systems. So that's the more regional or urban geographical system boundaries. But in return, you can look at more specifically fuels. You need also more data, obviously. In the case of the transport pricing guidance, we look specifically at gasoline, diesel, and electricity as fuels. But it is possible to extend the guidance to also the use of other fuels in a similar manner than it is shown in approach C for those three fuels. And the approach C compared to approaches A and B is a combined approach with bottom-up and top-down methods. And additionally to own price elasticities, we also need cross-price elasticities, which I will talk about in a minute. So I will first talk about those two parts, the bottom-up and top-down methodology. So the bottom-up travel activity data is what we need for car and bus transport. So individual car transport and public transport systems by bus. So you will need, as you can see here, much more data than for approach A. In this bottom-up approach, you need average vehicle kilometers, you need the travel distance, you need load factors, and you also need the average fuel consumption per vehicle kilometer. For rail transport system, we have a more simple top-down approach where you need electricity and or diesel use in the rail transport, and you need passenger kilometers in the rail transport system. So with this data, it's possible to apply approach C. Now, in order to look at mode shifts, which is one of the goals the country has in our example, to look at the mode shift from individual motorized transport towards public transport, you will need cross-price elasticities. So in contrast to the own price elasticity, we look at a substitute good here. We look at the price change of the substitute good, which may be gasoline in that case. So gasoline has a tax of 10%, plus 10%, and then that will have an impact on the demand of public transport. Maybe the rail system is electric, so the demand for that transport system will increase due to the price increase of gasoline. And the cross-price elasticity will then equal the demand change divided by the price change, again, which is in that case +2. Again, the guidance recommends to use country-specific values for those cross-price elasticities, but it also provides default values, which are presented in a similar way than the own price elasticities. The difference is that there is a differentiation between bus and rail transport systems, but the table, besides that, the table looks similar. Okay, and then finally, the greenhouse gas impacts with approach C. So what you can already see is that you need more data. I already emphasized that before. That's important. But the results then reflect more. They reflect mode shifts. They also reflect increasing capacity needs for public transport in passenger kilometers, which are induced by the fuel price increase. So you get more results. But you have to know, if you apply approach A and approach C on the same situation, you will have the impact in approach A is higher, because the increased public transport demand compensates a part of the emission reduction through the fuel consumption that is reduced by the tax on the fuel. So because you look at the mode shifts, which will increase emissions in, for example, the rail transport system, you will compensate a little bit of the decreasing emissions from the individual motorized transport system. It's important to know that also with approach C, obviously there are a lot of uncertainties. I mentioned that already with approach A. Again, we have maybe default elasticity values, which they are high uncertainty. So also with approach C, it's important to know that and to also present that in the results. Okay, and with that, I would like to hand back over to Urda and to start the Q&A session. Thank you for your attention.
Thank you very much to both our presenters, Sinclair and Felix. And thank you also for those who have already posed their questions. What I will do is I will copy the questions also into the chat function, so that everybody can also read the questions as we talk about them, to make it a little bit easier to follow. So let's start with the first question, which says, why is approach C limited to cities? Felix.
Yes, thank you for that question. There are two reasons. One reason is that the mode shift towards public transport is usually more visible in cities, or it's easier, because one important thing, obviously, with those mode shifts is that transport system users need to have the opportunity to do that shift. If there is no public transport, you cannot switch to public transport. So that's one reason. The other reason is that the calculations get much more complex if you try to compare or to include short range commuting in public transport systems and long range. So if you look at, for example, a long distance bus line, that's completely different than it is in an urban context. Public transport will work in an urban context, and because that's makes it much more difficult to assess if you have the whole system boundaries. That's the second reason why we restricted that to urban systems. But as stated before, it's possible to look at multiple cities in one country and to then improve the geographical area covered by the assessment.
Okay, thank you, Felix. Then there's a more detailed question on step 3, which reads, is there any basis to those assumptions about how transport behavior or transport demand might respond to higher fuel price, or is it just intuitive? So
yes, thanks
this
for
is a question to the price elasticity.
Yes, that's about the price elasticities. That's a very good question, and it's important to say that. So as I mentioned, price elasticities, no matter whether it's own price or cross price elasticities, the basis for determining such elasticities is empirical. So you would look at a situation and you would empirically find out how people react to such a situation. And as I mentioned, the elasticity values we use to determine the demand change are from a paper that's written by Carol Dahl in 2012 that's called Measuring Global Gasoline and Diesel Price and Income Elasticities. And she used a data set of such empirically defined elasticities to generate a globally applicable system of elasticities. And that means that those empirical elasticities, they include all possible effects of the price increase on demand. So that's also what people often ask. Rebound effects should, in theory, be included in that empirical elasticity value. That's in that empirically derived elasticity value. So the answer would be that yes, there is a scientific background to those values, an empirical scientific background, and it's not just intuitive.
Okay, thanks for that clarification. There's another question on elasticities, and this refers to what you mentioned about the different, also in approach C, the different elasticities for bus and rail. So why are those price elasticities different?
Yes, thank you. So, I mean, it's not very easy to distinguish that because we have, yes, thanks for going to that slide. First of all, we do not exactly know for each situation how much maybe of the rail transport system is electrified, how much runs with diesel. So that already makes it complicated. But I mean, the main difference would be that if you have a fossil fuel tax, that the bus would also be somehow would also have it would also have an impact. The tax would also have an impact on the price of bus traveling, and not so much on rail traveling. If you look worldwide, there is a partly electric rail transport systems. So that's one. I believe that's one of the reasons why those are not similar. And I would have to go into the paper. Yes.
Maybe I can just add another question, actually from my side, even though I'm the moderator. But so where bus prices are subsidized, this should not then have an effect, right? The increased fuel price should then not have an effect on the price of bus travel.
Yes, but again, that's the same situation. If we have an empirical elasticity value, and let's say this bases on a study that's made for the years 2000 to 2005, and in that time we had a subsidy on bus travel, then this will be an effect that's covered by the cross price elasticity. So if there is a price increase in gasoline, and you look at how many people switch towards public bus transport, and there is a subsidy, then this will be reflected in the empirically derived elasticity value. So in that case, yes, it would not have an impact.
Okay,
was that clear?
Yes, thanks. We have a different question, and this says, what are the impacts of fuel prices policies on the cost of transportation, especially air transport? So it's a little bit of a broader question to the fuel price policy itself.
Yes, first of all, I want to mention that the fuel transport, the fuel pricing guidance does not include air or water transport, so it's only ground transport. But I mean, it's possible to also raise a tax on air transport fuels, and then you would have a similar effect. I mean, you would just the demand would change due to the increased prices of the fuel, and then how much that demand changed, that I don't really know. You would have to look at a study looking at elasticities in the air travel in air travel. Yes.
Okay, thank you. And I also would like to mention, and sorry for not doing this earlier, that also from Vera and ICAT, we have also Jerry Seeger with us today. So if there's any more general questions also on ICAT, then and on the guidance, then we can also address it to him as well, because he was there since the very beginning of the development of the guidance. And in fact, there's been one comment on that. I would like to also mention here in the group and it says 150 pages is not very user friendly. Maybe there's also a comment on that one.
Yeah, thanks, Urda. This is Jerry, and hi everybody. My role here with Vera and on ICAT specifically is managing the development of the whole suite of guidance documents. So yeah, thanks for the brief intro there, Urda, and for the straightforward question about the length of the guidance documents. Of course, it's a very valid question or concern, if you will, that folks have raised about the length of the guidance documents. And our challenge, if you will, is to make sure that they're useful. And I think one of the things that we can, useful and user-friendly, I think one of the things we can do, having done this first draft, and what we wanted to do with the first drafts was get all of the content and the method down on paper. And then it was always ahead of us after that to figure out or to hear the feedback through the public consultation, through the country feedback as well, as these documents get used, figure out which bits people are finding useful and how they would like the documents presented and what kind of presentation would be most useful to them. So one of the things that we can do that we're discussing at the moment is how we might break things into modules. And so perhaps a first module could answer the question, what is this guidance and what can it do for me? And that might be more for the high-level policymaker who's interested generally in the guidance, and then leaving the longer guidance document for the technical analyst or the practitioner who's actually going to use it. And I think another thing that we can do better than we have done so far is help folks navigate through the guidance documents. As Felix laid out, we have approach A with a much simpler needs in terms of the data that you have and the expertise that you would need to apply that guidance. And that's a portion of the document. So if that's the approach that you're interested in, obviously you're not going to need the full 150 pages, but I think we can do a better job of helping people get to the information they need and get to that approach A, perhaps navigate that a bit more quickly so they don't sort of become overwhelmed by the 150 pages, many of which they don't need. So I think that's how I'd answer that, and certainly very happy for and welcome any more feedback on things like that and what we might do to address the concern about the length of the documents.
Okay, thank you very much for that clarification. There is actually another question regarding the guidance and on piloting the guidance. So it says, will you just calculate possible greenhouse gas savings, or will you evaluate whether the impacts really occur? This could be helpful to verify the elasticities as well.
Yes, thank you. That's a very good question. Actually, the guidance includes two possible assessments: an ex ante assessment, which is what I presented now, and an ex post assessment. And it is recommended to also apply the ex post assessment maybe after the some time has passed, which is covered by the ex ante assessment, in order to find out how the real development of the impacts has evolved, and that would be very helpful to verify the elasticities and maybe also to quantify the uncertainties that are that those elasticity values are bearing. Yes, that's a very good point.
And maybe just to add to that, because it was also presented by Sinclair that ICAT is actually entering the piloting phase later this year, whether you have already identified a country for piloting, or whether if there's anyone who says, oh, we would like to pilot the guidance, if this was still possible, and what sort of support ICAT could provide to those who are interested in piloting the guidance.
Yeah, thanks, Urda. I'll take that one. And good question. So as Sinclair mentioned, we're working with 20 or so countries, and among those, we'd like to use a number of the guidance documents talking about transport specifically. Of the ICAT partner countries, Kenya, Sri Lanka, India, and Costa Rica have so far expressed an interest in the transport pricing guidance. So it's relatively early stage in terms of actually using it, but of course we had to put together the first drafts, and it may be that we can finish work on the second drafts and have something that's the next version to use with those countries. And we're speaking with one other country as well. So hopefully 5 of the ICAT partner countries will use the guidance. And then beyond that, we very much would welcome anybody who would like to use the guidance if it's useful to them, and very much welcome feedback. Unfortunately, we don't have funds to support that. Can certainly be available for some training sessions and some support, but we don't have funds that we could actually give to others beyond the ICAT partner countries to use the guidance, but do very much welcome others using it, and we'd love to hear from them and support where we can.
Okay, thank you very much for these clarifications. We actually have one participant who says they're interested, so I'll connect you to, I think, after this webinar.
Okay, that's wonderful. Great. Well, thank you very much. Very nice to hear from you. So I look forward to following up.
And then if there's any other questions, so we've answered all the questions that have come in by now. If there's anyone who would like to pose another question, please do so. Otherwise, of course, you can also follow up with us afterwards if there's any more questions coming up. And there's also going to be follow-up communication, of course, from ICAT on the use of the guidance as well. And in addition, I would also like to take the opportunity to advertise our upcoming webinar. As I mentioned in the beginning, this is a series, and we will present the methodologies of each of the 8 chapters of the different mitigation action types. And the next one will look at vehicle fuel efficiency measures, and will be moderated as well from a colleague of the UNFCCC Secretariat then that time, and also include colleagues from UNDP who have worked on a electric BRT project, and that methodology is included in the vehicle fuel efficiency chapter of the transport volume. And maybe just to also say that again, because Felix mentioned it in the beginning, that of course the chapter on the pricing policies in the transport volume is very short. That's because the purpose of the volume is really to give an overview of the existing methodologies and a first, step into how it works generally, but it's not an idea to replicate all the methodology documents that exist, which can then be done in the background documentation, as in this case in the transport guidance. So unless there's any more questions, I would say that we close this webinar a little bit earlier, and I would like to take the opportunity again to thank everybody, all the speakers in particular, but also everybody who participated and showed interest in our methodology work. And we're looking forward to hear back from you and to follow up with you afterwards as well. So I don't see any more questions coming in, so I say we close it here, and we look forward to seeing you again online at another time.
Thank you, everyone.
Thank
Okay,
you.
thank you.
Bye.
Thank you, goodbye.